This is a transparent LCD, and it looks like we just took an LCD and took the backlight off, but that's not true. There's actually been a lot of work that Samsung has done to create, to improve the transmission quality of this display so you can truly see an image from behind it. And so you can think of different applications that they're thinking about, like putting it in a microwave, or putting it in, for example, in a grocery store in the freezer door. When you're looking at freezer doors, you can actually have, overlaid items on top of the food, which is kind of a neat application, or prices and price tags, etc. But for the sake of this current demo, we're using the transparent OLED, and what we're doing, and Jinna's going to talk to you about the new interaction model that we've created, where we're using two Kinect cameras to create a view-dependent rendered image, while at the same time capturing 3D gestures from behind the screen. Jinna?
Yep. So we have, as Stevie introduced, we have one depth camera here, the Kinect camera, that captures my head position. So we're rendering gaze-corrected 3D view of the virtual world that's behind the screen. And we have another camera here that looks at my fingers behind the screen. So you can see how my gesture is detected by the depth camera. So it's almost like overlaying this virtual 3D space onto this physical world behind the screen. Then we can interact directly with this virtual world behind it. So I'm going to introduce 3 applications about how we can apply this interaction technique in the productivity space. First application is 3D object manipulation. So because it's doing gaze-corrected rendering, I can look around this model to get the better view of the 3D contents here, and I can also directly grab it and move it around as if it's physically there. So it's kind of confusing from the camera, but from my point of view, or the user's point of view, it almost feels like the virtual model is actually in my hand behind the screen. And this 3D grid and the cursor that is mapped to my finger is really helping you to get the better feedback about how the 3D thing works. I can even use my 2 hands to scale it up or scale it down. So it's by manual manipulation. And can move around. So that was 3D object manipulation. And second application is for switching tasks or switching applications. So what's interesting about this setup is we can just work on this keyboard as in the 2D traditional computers. So I can search through internet and browse the web. And but as soon as I raise my hand, you can see what's behind this main window. So it's almost like you're entering this virtual world with your hand by simply raising your hand. So I can click, which is pinching, another task, and that pops up, brings that to the foreground, and I can switch to another task. So so all you have to do to switch tasks is just reach out with your hand and go and grab them, and that just lets you grab and switch to the different task. So we're creating this 3D space where windows or files are floating over your hand above the keyboard. So it's very easy to transition from normal everyday task and this 3D interaction. And the third application we're going to show today is for file management. So here's a virtual cabinet, which is sort of equivalent to the folder but in the 3D space. So I can expand it by pinching it, so you get the better view of what's inside the folder. So I can look around to get the better understanding about the contents inside, and I can click, which is pinching my gesture, this application that pulls up the Skype up to your foreground, and then you can just do everyday tasks with the keyboard, and you can just pinch again to make it go back, or pinch to close the cabinet, and so that's the basic interaction modalities that we're exploring. So we're really excited about this potential of having this 3D space where the pixels and your hands are co-located in the same space, and what kind of operating environment can arise in this research space.